All right, I'm going to do a quick video going over how to do the algebraic manipulation on these equations. So I'm going to do 3 different equations that are from the assignment that I gave you. And this is the first one, and we are going to be manipulating it to find A. So as soon as I know what variable I'm going to be looking for, I'm going to identify it in my equation. And ultimately, remember, what we're looking for is this variable, A, is equal to lots of stuff. So this is what I need in the end. So I have to isolate that A, that acceleration variable. So my first step is going to be to look at the side of the equation that has my variable. So on this side of the equal sign, there are 2 terms, one of which contains A and one that does not. Well, I can't do anything with the other variables in the term that contains A as long as I have another term being added or subtracted from it. So I need to isolate the term that contains A before I can do anything else. So to do that, my v naught t is being added to the 1/2 at squared. So I'm going to do the inverse of that, and I'm going to subtract v naught t from both sides. So my next step then is these 2 become 0, and I'm going to rewrite my equation. So delta x minus v naught t is equal to 1/2 at squared. So I always write the any term that has a negative sign. I don't ever put that in front, even though negative v naught t plus delta x is algebraically correct. If I do that, I'm very likely to lose that negative sign in front, and I don't want to do that because it makes a huge difference in any answer that you get. That negative sign is important. So we usually put the negative signs on the inside just so they don't get dropped in translation. All right, I am still looking for the A, but now the term is isolated. So my next step is going to be to get rid of the other term, the other variables in this term. So I need to remove the 1/2 and the t squared, both of which are being multiplied times A. So I'm going to start by getting rid of the 1/2. And since 1/2 is being multiplied by A, I have 2 options. Or basically, I need to do the inverse, which is divide. Now, if I take this and I divide by 1/2, when I have a fraction in the denominator, that becomes just the reciprocal of the fraction. So rather than dividing by the fraction, I can just multiply by the reciprocal. So in order to move the 1/2, I can multiply by 2, since 2 over 1 is 2. And that will cancel out my 1/2. And so then I have to multiply by 2 on both sides. But be careful, because right now this is not correct. The 2 is being multiplied by everything on this side. So I have to have parentheses. I can't just have the 2 out front, or it will be just 2 delta x minus v naught t, and that is not right. So to rewrite this, we have 2 times delta x minus v naught t is equal to a t squared. So again, we are looking for the a. It's still being multiplied by t squared. So since it's being multiplied by t squared, my inverse to move it is going to be to divide by t squared. And now I just need to rewrite the equation so that I have everything equal to a. And this is a perfectly valid explanation, or perfectly valid equation. But just know that I don't like writing it like this, and I will automatically convert it to this form here. I like things A equals stuff rather than stuff equals A. So I'm usually going to go from this part straight to writing it like this. So if I skip the step and I don't write this, but go straight to this one, that's why. Just stop me and ask the question. All right, let's look at this question. This was the next most requested question or equation for you to manipulate. And in this one, we are solving for r. So ultimately, we went r equals stuff. Now, in this one, we have r squared. And I could undo the square now, but that means undoing a square is taking the square root of both sides. And that's going to get very messy very quickly. So I'm going to go ahead and solve this whole thing for r squared and do my square root at the very end. All right, so this is a special case and isn't going to go exactly with the instructions that I have on the board in the classroom. Whenever you have the variable you're looking for in the denominator, your first step, as soon as you can, is to get it out. If you have your term isolated, you want to get that term out, or that variable out of the denominator. And since it's being divided into something, the inverse is going to be to multiply by it. So I'm going to multiply both sides by r squared. And then I'm going to rewrite my equation. Like this. And r squared is still what I'm looking for. And notice we have the big G times m1 times m2. In the very beginning, that big G is pulled out front and is not part of the fraction. It's being multiplied by the fraction. The reason the big G is out front is because it's called the universal gravitational constant. And so they just put it out front because it is a constant. It's 6.67 times 10 to the negative 11. And so they just don't put it as part of the fraction because they just separate it out as a constant. All right, so our next step, we're trying to, again, isolate our r squared. So right now it's being multiplied by f sub g. So I'm going to divide by f sub g. And then again, rewrite the equation. And now we just have r squared. So I'm going to turn it into r by undoing my square. Now I'm at the end. So undoing the square is going to be taking the square root of everything. And there's two different ways that I can write this. I can write it as r equals the square root of g, m1, m2, divided by f sub g. And this is perfectly fine. But oftentimes you write quickly and you don't make the square root sign big enough, and you might miss the fact that it's the whole equation and only have it applied at the top, and it can get messy. So sometimes you'll see me write it like this. Instead of the square root, I use parentheses, and I use the exponent that means square root, which is the 1/2. So those are algebraically equivalent. All right, let's look at the third one, and I'm going to go ahead and I'm going to solve for k. This is the period of a mass spring oscillator. That's what this equation is. And this one, again, is a little bit messy because not only is our variable in the denominator, but it's also inside a square root sign and being multiplied by something else. So looking at this, I want to try and just get this square root sign by itself. So I'm going to go ahead and just divide by 2 pi. And rewriting that, I'm going to have my period divided by 2 pi is equal to the square root of m over k. So again, looking for k, now it's inside the square root sign. I just need to get it out. So I'm going to square everything. And again, rewrite it. So we have t sub s squared divided by, now 2 squared is 4. And since that's just a number, just go ahead and write it. And then pi, we don't really want to multiply that out, so we're just going to do that as pi squared. And that's going to be equal to m divided by k. So now our k is finally accessible. So now, since the k is in the denominator, I need to get it out of the denominator. So I'm going to multiply both sides by k. Now, if I was actually solving this for m, here's the answer. We'd be done. So k times t sub s squared divided by 4 pi squared is equal to m. But since I'm looking for k, my next step is going to be to get rid of all of this. And I can just divide by t sub s squared on both sides and then multiply both sides by 4 pi squared. Or I'm going to just multiply by the reciprocal of this fraction. So I'm going to multiply by 4 pi squared divided by t sub s squared, multiply by 4 pi squared divided by t sub s squared. And then my last step, rewriting, and move it up here, k is equal to 4 pi squared m divided by t sub s squared. Now I move the m over here to the end just because it's usually easier to have your constants in the beginning. It's just the way, I don't know, the way we're used to seeing it. So that's it. If you need any additional help, please ask.